Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, today we're going to work on some output transformer testing. And this is kind of a confusing topic, and at the end of the day, it's pretty simple. You basically have a turns ratio that is the primary to the output, and you square the turns ratio, you multiply it times the ohms load, which is reflected back to the primary. The transformer itself has no impedance. It's reflecting the impedance of the load back at the tube. And that's why the speaker you use on a tube amp can be pretty critical on how good the tube amp works. So, we're not getting into speakers today. We are going to get into measuring turns ratio and then the phasing of the primary to the output. Also going to dive into an issue I had with a mismarked transformer that impacted how it performed. And I didn't even realize that's what's going on. And so it kind of points to when you're building an amp, especially if you're using transformers that maybe aren't super mainstream stuff, to double check them with your scope and your signal generator. And we're going to be using this old school Tenma audio generator, and then I have my 2235 Tektronix scope. And I'm sure there's other stuff you can use. You know, there's plenty of other signal generators. I got this old analog stuff that's got knobs on it just because I like knobs instead of menus. So anyway, I'm going to show you the results from testing some various transformers. We're going to start off with like a known one, which is an ISO Tango transformer, go through EdCore musical power supply. Then we're going to be testing and figuring out what this new Sound 6P1 has as far as output transformers, and if these transformers are going to be usable for what we're wanting to do. And then finally, we're going to check the stock R8 transformers to see what they actually are, and then show you how to mark the phasing of them so that if they're repurposed into another amp, you know how to wire them up. So let's get busy testing some transformers. Okay, so we got our old trusty Tektronix 2235 scope out, and we're going to be running some tests on some output transformers, and we're using our Tenma analog audio generator. So first thing we're going to test to kind of get a baseline is we have a ISO Tango FC20S, and this is a multi-tap transformer, and it's got the phasing marked on it. And so the common or the ground on this one is in phase with the plate of the primary. So we're going to hook this thing up, and the way we're testing this is we're going to be injecting a 1 volt signal into the secondary, and then we're going to be reading the voltage on the primary. And I've got this first knob here set to a 0.5 volt per unit. So it'll take 2 bars to equal 1 volt. It just gives us a little more resolution. And then on the output, or the second channel, we have it set at 5 volts per unit. And that should give us close enough resolution to be able to see what's going on. So let's hook up the signal generator. And then we're going to turn this back up till we get 1 volt peak to peak on our input that's into the secondary. And then we'll pull this up here. I need just a little more. My old scope is a little jittery, kind of like I am sometimes. After it warms up for a while, it gets a little more stable, but it works. Anyway, so Here we are with the upper traces are 1 volt peak to peak on the secondary, and then, oops, knock the lead off. And then here's the output on the secondary, and you can see these are in phase because they're both, curved the same way together. So we count 5, 10, 15, 20, 25 volts peak to peak on the primary with 1 volt in on the secondary. So that's a 25 to 1 turns ratio. So the math is you multiply 25 times 25, or 25 squared, and then you multiply that times the impedance. Now the 25 times 25 is, I think, 625, and that is your impedance per ohm ratio. So for every ohm on the output, you're going to get 625 ohms on the primary. So we multiply that times 8 ohms, and we get our 5K, which is what's showing on the scope. So let's hook up another transformer. This time I'm going to hook up a 5K ED core, and on this one they don't have the dots on the diagram that I like to see, but they do show, if you assume that the diagram is drawn correctly, and this is what it looks like, that the common is in phase with the B plus on this transformer. So let's see if that is in fact the way this thing is wired. So we're going to hook the positive of the output, or the secondary, which is the yellow wire, to the positive of the signal generator, and we're going to hook the negative to the white. And then on our second lead, or the second channel, we're going to hook up the positive to the plate and the negative to the B plus, because it looks like that's the way they've got these phased. And so let's hook up our ground to the signal generator, and let's correct some voltage in here. We get back to our 1 volt peak to peak, and we're back to our 25 volts on the primary for 1 volt on the secondary, which is the same 25 to 1 turns ratio, which we determined from the last transformers of 5K. So got another 5K. This one's phased 180 out from the other transformer. As long as you know which way it's phased, that's all good. So the next one, and this is one I'm going to show you that had an issue with, it was a musical power supply version of this 15 watt 5K. This is one of their high fidelity units that is designed for hi-fi use. It has an ultralinear tap, and after I got these from him, he sent me an email and said something like, well, I'm sure you figured out that I had the label wrong. And I was like, no, I didn't. What are you talking about? And it looks like that he swapped the plate and the B plus so that the ultralinear tap was a 60% instead of a 40%. And I discovered he was right when I connected it up with an ohm meter. He definitely wired them up backwards, or had the color codes backwards. So I wanted to hook this thing up on a scope and just see what it looks like and how it's phased if I hook the primary leads up correctly. And if you remember right, even though these musical power supply transformers had lower distortion, they didn't sound as good to me. And I'm sure that's why, that the ultralinear tap was at 60% instead of 40%, which would make it have less distortion, but it wouldn't be as lively sounding either. So let's hook up the test leads on the output, And this time I'm going to reverse them from what we did on the other transformer, and I'm going to hook the positive to the plate and hook the negative to the B plus, because they need to be swapped, or how they're marked. I hope that's not too confusing. I mean, it was really confusing to me too. So let me connect up our ground lead here to the signal generator. And we got 1 volt peak to peak in. We have our 25-to-1 turns ratio. So yes, this is another 5K transformer. So the other thing though I want to check is, what do we get when we hook up to the ultralinear tap? And when we adjust this back up, now we've got approximately 10 volts peak to peak on the ultralinear tap. And if I reverse this the way it was originally connected, you can see how much higher the turns ratio is when we go to the what would be a 60% tap. So yeah, definitely had this wired up backwards, and through no fault of my own, the bottom of the transformer was marked incorrectly. And he did send me a pair of some Z11 lamination transformers that he said, yeah, I got those color coded right. And when I checked those, they are correct. So I've got about 5 pairs of these, or 4 more pairs of these musical power supply transformers. And now that I know how to wire them up correctly, we're going to have to build an amp with them and see what that sounds like. And that may be as good or better than those Ed cores are. So, got that sorted out while I've got this stuff all set up. So the next thing I want to check is this little Noob Sound 6P1. And what are the transformers in this guy? So now we've got the signal generator hooked up to the secondary leads of this transformer. And it originally had the green wire connected to the 8-ohm tap and the black lead connected to the ground. And now we're going to see what turns ratio we have on the primary, or what voltage we have. And we hook this up, turn our voltage up, and you can see we have a much lower turns ratio. We've got 5, 10, 15, 17 and a half. We multiply 17 and a half times 17 and a half times 8, and we get a 2.5K output transformer, which isn't going to work for what we want to do. And it's theoretically correct for having a pair of those 6P1 output tubes, because individually they would want to see a 5K output, and when you have a pair, theoretically you're supposed to cut the impedance in half, but in reality, when you're driving an output transformer with a parallel pair of tubes, you really would need something closer to like a 3.5K. And so the impedance on these transformers is a little low from what would be ideal for running a pair of tubes. But we do have another wire here, and I'm not sure what this one is going to do. My hope is that this other secondary connection is for a 4-ohm, and if it is, that should get us to the 25-to-1 turns ratio that we need for this transformer to work with what we're going to be doing. And bingo, there we are. Turn that down just a breath again. Here we go. There's like 1 volt peak to peak on the secondary, and there's our 25 volts on the primary. That is showing us we've got a 25-to-1 turns ratio, and we got ourselves a 5K output transformer. So, bingo, there we go. So the last transformer we're going to hook up today is going to be the transformer that we pulled out of the R8, and I want to figure out how it was phased and then mark it so that in the future, when I go to use that transformer, I'll know how it's phased. Or if I decide to sell them, that the next user will know what phase is which. And so we're going to do the same thing. we're going to come in here and hook up the 8 ohm secondary winding to our signal generator with the positive on the 8 ohm terminal and the ground to the ground terminal, or the common. Then we're going to come in here and see what our turns ratio is from anode to anode. And so that would be from one blue lead to the other blue lead. And this is an example of it being out of phase. So whichever way this is connected is 180 degrees out of phase. And again, we have our 25 volts peak to peak on the secondary. It's kind of hard to see here. That's just about 1 volt in. And then we have 25 volts anode to anode. That means that from plate to plate, we've got a 5K output transformer. So what I need to do now is reverse these two anode leads and then mark the transformer that the 8 ohm is in phase with the anode lead on the output transformer that's the positive, and that's how you can determine what phase the transformer is, or which anode lead is in phase with the positive output lead, so that you know, if you're dealing with global negative feedback, which anode needs to go to which output tube to get the transformer in the correct phase for the amplifier it's being used in. So if you got a signal generator and you've got a scope, it's a fairly easy thing to do. And obviously you could do it in the reverse direction. You could put 25 volts, or you could put a voltage into the primary until you ended up with 1 volt on the secondary, and then see what that volts peak to peak is on the primary to get the turns ratio. It doesn't matter which direction you stick the voltage in. It can either be a step up or a step down. And I'm using a 1K signal. If you wanted to have some fun playing around, you could see like what this ratio changes to at different frequencies. And I'm sure that the higher quality of the transformer, the impedance will stay the same regardless of the frequency, at least in the audio range. And the crappier transformers maybe won't, and the impedance will shift around with the frequency, which would cause weird stuff. You could also do the same deal like I was showing you with the single-ended amplifier. If you want to try to figure out what the ultralinear tap percentages are, you can do the same deal and figure out the turns ratios and then calculate up what percentage of the tap that ultralinear tap is. So that's a helpful tool too. And to make sure that they're not reversed like we saw on that musical power supplies transformer. So this is a cool tool for checking transformers, and I hope this was helpful. And I'm glad to see that there is a way to get the output transformers on this Noob Sound 6P1 to 5K, and that will allow us to move forward with our project. So this looks like a great place to wrap up this video. Well, I hope you found this tutorial on measuring output transformers informative. And it is kind of a confusing thing. It took me a while to kind of wrap my brain around this whole reflected impedance and the impact that the speaker has on the load on the output tube and all that stuff, and like what kind of plate load do these tubes want to see? What does increasing and lowering it cause as far as distortion versus power? All those sorts of things. In my experience, it's usually better to err on the side of too high an impedance than too low. When you get too low, a lot of times you just end up with a lot of distortion, and the amp just doesn't sound good. And yes, you give up a little bit of power going to a higher impedance, but the ratio of power loss to distortion loss is pretty big. It's not one-to-one. So anyway, I'm sure there's plenty of other tools you could use. I could have probably used my Analog Discovery 2, but I've just gotten used to using this dinosaur audio generator and this analog scope that I have, and hey, it's fun to just break this stuff out every once in a while. Like I said, I'm sure you could probably set the output of the Analog Discovery 2 to 1 volt and then measure the other side and get the same results. So yeah, leave in the comments below if you've been able to do that or what kind of test equipment you use. And yeah, this is just something that's part of dealing with tube audio gear. And I haven't done this in a while, and so I kind of went through a whole bunch of transformers that I've been waiting to get all this stuff set up to test. And so now I'm ready to go. And the good news is, if we use this yellow wire and the black wire and just tape off this green wire, which was used before, then these are 5K output transformers, and they're going to work for this conversion to the BG, I think it's called a BG-SE-1 or something like that. That's what people have called it. Anyway, little Pentode EL84 should make, pushing 4 watts, which is way more than this thing makes. It's not quite what it's ever tested as, but hey, and if you wanted to experiment with doing it as a parallel single-ended, you could use the green and the black wire, have a 2.5K, see what that does. Hey, that may be something we try in the future. So it's fun just experimenting with this stuff, and it's been a project that I've been putting on for way too long. So now that we know that this is going to work, we can get busy. This is my personal one that's like extra gutted. The other one, I need to gut it, kind of figure out what we're going to do, see what kind of parts I need, order some parts, and get busy building that into a cool, basically a new amplifier. So anyway, if you're enjoying this content, please subscribe to the channel. Please like the video. Thanks to all you other folks that help support the channel, you regular viewers and subscribers, and yeah, just really appreciate all you guys. Really helps keep this channel growing. So, till the next video, have a nice day.